In this project, we designed and implemented a system that uses a remote-control car to collect information by driving over and scanning radio frequency identification tags embedded in the road surface using an RFID reader. The RFID reader and antenna, as well as a computer, are installed on the RC car. Once the data is scanned by the RFID reader, it is then transferred to the computer via Ethernet. After the information is received by the computer, the data is transmitted via Wi-Fi to the server. The server then stores this information into a database. By querying the database using the ID numbers of the tags and RC car, information about the car's location can be procured. This information can be accessed through a web application or smartphone applications.
The laptop on top of the RC car is remotely accessed by another computer. This way we can run the program that controls the RFID reader and its antenna. In order to read the tags, we will first need to click Start Inventory Run on this program. Once we do that, as the car drives over the tags, we can then see each one. Once the information is turned red, that means that particular tag is no longer being seen by the antenna. Once we have ran over all of the tags and collected all of the data we need, we will hit Stop Inventory Run, and we will save this file as a text file so that we can input it into the database. Now the file is saved in the correct directory, and we can use a command prompt to send it to the database. Once we have opened the command prompt, we will change the directory to the directory in which we just saved the file. Once we have done that, we will run a curl command which will open a PHP file on the server and insert the text file into the database. Once we have entered the command, we can log on to the web application to see our results. If we scroll down to the RC car table, you will see all the data that we just inserted from the text file. The RC car table at the bottom of your screen displays what RC car drove over what tag at what time, as well as other information collected about the tags through the RFID reader. At the top of your screen, you see the tags table, which corresponds to the RC car table through the tag ID. The tags table contains more information about the tag's location. Using this information, you could follow the path of the car and know its location. Each of the columns at the top of the RC car table have a specific meaning. The RC car ID displays which RC car picked up the tag value. The tag ID is simply the number of the tag. Timestamp is the reader timestamp in Unix epoch time. Run num is the run number. This is used when conducting multiple runs. RSSI is received signal strength indicator. The reader is the reader that received the tag. Frequency is the specific frequency the reader was on when reading that particular tag value. Power is the specific reader transmit power for that tag to be read, and antenna is the antenna port that received the tag read.
This particular video will walk you through the Android application for the vehicular network testbed. The first screen that the user will go into is the login screen, where they can type in their username and password. For this demonstration, we will use the username TeamFire and password TeamFire. So after you enter the username and password, you will hit the Submit button. After you have logged in successfully, the next screen that you will go to will give you an option to select a table. You will select the RC car table and hit Submit. Once you've hit Submit, you will be taken to the next screen where you can select one of four options, either Insert, Update, Delete, or Display. For this demonstration, we will use the display to look at the information that was stored into the database about the RC car. So you will click Display and hit Submit. On the next screen, you'll see a long list of tags that have been entered into the database. You can select any one of which you would choose, but we'll just select one of them for our demonstration. So we'll pick the first one. When you click on the tag ID, the next screen will pop up the particular information that correlates to that tag. For administrative purposes, the web application, the iPhone application, and Android application have the delete, update, and insert functionality. These functionalities will not be necessary in the final version, where the user will only need to display the RC car table.
There are several reasons for creating a tracking system with specific detail. For one, it will give drivers better directions. Knowing which lane one is in can help drivers navigate complicated intersections and road exchanges. Sometimes a GPS system will recognize the car as continuing on a road when you have actually exited. Additionally, in the case of an emergency, rescue personnel can know exactly where an accident occurred and make their way directly to the scene. Drivers that might be affected by the incident could be directed around the accident or given a different route to avoid traffic. Finally, a potential for having very specific location data would be for the development of self-driving automobiles. For example, if there are multiple RFID readers on a car, eventually the location of different parts of the car could be recorded and used to keep cars from hitting each other.